Now we'll be getting started with integration. You know, integration means previously we have studied about differentiation, right? Integration means it's a reverse process of the differentiation. Okay. So here, wherever we got, for example, this d by dx of 2x square plus 5, let it be 3x square plus 5 like one function. We can find the derivative, right? So what is the derivative of this? 6x. Now integration that investigates what would be the reverse form, what would be the antiderivative of 6x before getting derived, how it was actually. Okay, like that it is there. So we call integration an antiderivative. Okay, so let's consider a function f of x, right? The integral of f of x dx will get some capital F of x, right? Some other answer we are getting, that I am marking it as capital F of x. Here this sign over there is called as integral sign, integral, and this guy in between this is called as integrand, and this is with respect to the variable, which variable like it denotes. Dx means with respect to x. Integral of the function in the integral of the integrand function f of x with respect to x. That is what this means. Okay. Now this is some capital F of x means how it was actually means that f dash of x, this function's derivative is our f of x. That's what this means. Suppose here integral of 6x dx means we might be getting 3x square plus 5, right? So this is what capital F of x. This is small f of x. Now you say, what is capital F dash of x? Is 6x, right? Okay, that is the basic form. Basically how we can understand integrals. Okay, in the sense. But I have a doubt. I said that for this function's derivative is here. What about this kind of function? Like suppose I am getting 3x square plus 7. Are they same function or different function? Different function. What is their derivative? So, as we are talking about antiderivative, before it is getting derived, it may be of the form 3x square plus 5 also, 3x square plus 7 also. Or it may be some other 3x square plus 1728 also. That like how many choice we have for this constant term? Infinitely many choices are there. That could be of any one thing. Are we sure it is from which one? Which function's derivative is 6x? So to avoid this confusion, we are keeping plus c, some non-zero constant. So we call this as constant of integration. Okay, understood? The same way f dash of x, this capital F dash of x is nothing but f of x plus c whole dash is our f of x. Alright, any doubts on this? That is how basically integration works. Previously in differentiation we have studied the what principle? Some principle is there. First principle. Likewise, did we use for all the derivatives the first principle? Then what did we use? we kept them as the formulas. After applying first proof, something came as the answer. We use them as the formulas. Likewise, here also we have some other formulas. Okay, likely it's an antiderivative form. Okay, whichever the things comes in like a derivative, that will be the inputs for this integrals. Okay, the basic integration formulas we are going to see. Shall I erase everything? So the first formula, integral x power n dx, provided that n is not equal to minus 1. N should not be equal to minus 1. Then it is called, the integral is x power n plus 1 by n plus 1 plus c. Okay. And suppose I said n should not be minus 1. What if n is minus 1? It is 1 by x. Is it? Here x power n, I said n should not be equal to minus 1. So, if it is equal to minus 1, we get 1 by x into dx equal to log x plus c. We will be asking for which function the given thing is a derivative. Okay. And here is our guy, e power x. Which function's derivative is e power x? E power x only. So it is e power x plus c. And integral sin x dx. See, previously we have studied d by dx of cos x is equal to minus sin x, right? Just transpose this dx over there. We get d of cos x equal to minus sin x into dx. Now integrate on both sides. So what is the value of our integral sin x dx? Here integration differentiation gets cancelled. Okay, not like that. Here 1 is there, right? We'll be applying the first formula. What is the formula like? But here the constant is, sorry, with respect to cos x we have to integrate. Okay, but simply we'll say integral differentiation will get cancelled and we get cos x is equal to minus integral sin x dx. We need integral sin x dx formula, so transpose this negative over there. So we have negative cos x plus c. Same way, integral cos x dx sin x plus c. Okay, and integral tan x cot x and all will work out later. The basic initial formulas requires, it's from antiderivative, right? So this is all easy. In the basic differentiation formula, do we have formula for tan x? What is derivative of tan x? Secant square x. Then integral of secant square x is tan x. Understood? Likewise, think of another differentiation formula. Derivative of cot x. It's not minus cosecant square x. Cosecant square x dx is equal to minus cot x plus c. And integral secant x tan x dx is equal to secant x tan x is the derivative of secant x plus c. And integral cosec x cot x minus cosec x dx. Sorry, minus cosec x plus. Okay. Same way, we have studied formulas for derivative of sin inverse of x, cos inverse of x, tan inverse of x and all, right? Then integral 1 by root of 1 minus x square dx is equal to either it is sin inverse of x or it is minus cos inverse of x. Alright, because we have two formulas, right? Likewise, integral 1 by 1 plus x square dx. So either it is tan inverse of x or minus cot inverse of x plus c man. That c is important. Okay, the same way integral 1 by mod x into root of x square minus 1 into dx. This sec inverse of x or minus cosec inverse of x. Okay, but I have a confusion. Where to get minus, where not to get minus? Is it? Sometimes unintentionally or intentionally we might commit a mistake, right? Derivative of sin x is minus cos x, like we'll write it. To avoid confusion, I will follow one simple thumb rule. The thing is, whenever in differentiation, the question has the thing that we are about to derivative has the alphabet C, we get the negative in the answer. Whenever differentiation, you look at it, derivative of cos x is what? Minus sin x. Derivative of cot x is what? Minus cosec square x. Okay, derivative of cot x into cosec x is what? Cosec x minus cosec x. Okay, likewise I said in differentiation question has the alphabet C. In integration, if answers has the alphabet C, because technically here answers are their questions, right? So in integration, if answers got the alphabet C means we get the negative as the answer. You look at this, whenever we get C as the answer, if we wrote cos x, right, we kept minus or not. We wrote cosec x, right? Sorry, cot x we wrote negative. Cosec x we wrote negative. Here also cos x, cos inverse of x negative. Cot inverse of x negative. Cosec inverse of x negative. Understood, right? You won't be able to confuse, right? But simply remember this, whenever in differentiation question has the alphabet C, we put the negative. In integration, answer has the alphabet C, we put the negative. Got it? So these are all the basic things we need to know about integration. And next, properties of the integration. Properties are, wait a minute, why we have to study the properties? Didn't you notice the structure? Whenever we study a new thing, immediately what we'll study? What could be the sum, difference, multiplication, division, everything. Is it? We have studied about integration right now. Then how to find the sum of two functions and their integral. Suppose we have two functions f of x plus or minus g of x. The other way add or the subtract. First we'll add. Okay, it is equal to finding their individual derivatives and adding them. Okay, and we have a constant multiplication. Suppose a function multiplied with a constant. How do we treat the constant? You remember? As a curly leaf. We'll keep it aside. Then k kept aside, the integral of f of x alone can be calculated. And That's pretty much everything, man. Only these two properties we have. Constant multiplication, two functions added or subtracted. Addition, subtraction also the same. And then composite functions. F of g of x. So it's a composite function means integral f of g of x dx means how we can integrate them. First we have to find d by dg of f of x, that means f of g of x into dg by dx into dx. Okay, seen this somewhere? Using chain rule. Alright, so our final answer will be f of g of x, like will be the final answer. Sorry, f dash of g of x. Oh, why I kept f dash? Anyway, we'll see how this works while doing some examples, right? And one important thing, if integral f of ax plus b into dx, suppose the variable is of the form, inside the function, it's a composite function again. Okay, suppose this variable is of the form ax plus b, then we'll be getting capital F of ax plus b divided by a plus c. Okay, we'll be seeing some examples for this. By the time you may able to understand. Okay, this may be confuses you at this time when you see, but when you come back here and look at all this, this may make sense. Got it? We'll see some examples. Some basic examples. Root x plus 1 by root x. So let us everything. Integral root x plus 1 by root x dx. How this works? What form is this? We do have a direct formula. It's a sum of two functions. Okay. If we multiply them, cross multiply and do them, we don't have a formula, right? Like differentiation, we don't have uv and u by v. Product rule, division rule, we don't have. Okay. But we do have, but later. So here, this can be treated as an individual function. So individually we find the derivatives and we add them. Integral root x dx, but we haven't studied the formula for the root x and all, right? It is of the formula of the form x power n, but x power what will come here when it is in root x? Good, x power 1 by 2 dx, here x power minus 1 by 2 dx. Now as per the formula x power n dx, we have x power n plus 1 by n plus 1 plus. Now here what we may get, x power 1 by 2 plus 1 divided by 1 by 2 plus 1 plus c1, because two integrals, and then plus x power minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1 plus C2, and this can be written as x power 3 by 2 divided by 3 by 2 plus C1, and then here x power 1 by 2 divided by 1 by 2 plus C2. Now combine these two x terms, that C1 C2 now. Okay, so here it is 2 by 3 x power 3 by 2 plus x power 1 by 2 2x power 1 by 2, right? 1 by 2 means goes up, and then C1 plus C2. From these two terms, any simplification possible means we will take root x as common, right? Because this is x power 1 plus 1 by 2. So when we take 2 root x as common, because 2 is also same, then we may have x by 3 plus 1 plus a common c, where c is equal to c1 plus c2. That two constant together, I took it as a single constant. Okay, and then here this is 2 root x into, based on the option man again, x plus 3 by 3 or else 2 by 3 root x into x plus 3 plus c. Which format the option is, that format we can write. That is how this integration works. Got it? Suppose we have the next example. Shall I erase everything? So the example 2, integral 4 minus 5 cos x divided by, not 5 cos x, 5 sin x divided by cos squared x dx. Do we have any direct formula for this? No, we don't. This can be splitted as the separate functions. Is it possible? We don't have a division rule either, right? So we can split them. Is it possible to split? 4 by cos square x into dx minus 5 sin x, using that f of x plus g of x. I am doing all this. Okay, and then do we have a formula for 1 by cos square x and all? No, we don't, but we do have a formula for secant square x. What is 1 by cos square x? Yeah, but we have a constant over there in the numerator. How do we treat a constant? It's a curry leaf. Keep it as it. Then 4 take now secant square x dx minus 5 kept aside. We have sin x into secant square x, like you can write, or else you can write it as sin x divided by cos x into 1 by cos x. Why I am taking this call? Because we don't have the formula for sin x into secant square x either, because they are in the product form. We don't have the product form at all. Okay, but if I return this form, what I may get? Tan x into sec x, right? Do we have a formula for that, the direct formula? Yes, we do have. So this can be written as 4 into integral secant square x dx minus 5 into integral secant x tan x into dx. What is the integral of secant square x then? Tan x plus c1 minus 5 into integral secant x tan x, that is secant x plus sec. So this can be combined 4 tan x minus 5 secant x plus c1 plus c2. Sorry, that plus c, like I made, right? Where this c is c1 plus c2. This is for descriptive examination. In objective examination, we don't do all this. Simply we find the integrand, we'll put 1 plus c. That's all. That's it. See, this c is c1 plus c2. That's like I combined as a one constant. Sometimes with this constant C, if we have log A, this is also constant, right? Sometimes cos A also will be there separately. All together we'll keep it as a one constant. That's all. But we have to mention in the descriptive examination. Understood? Any other doubts? Okay, good. So based on this, I'll give you a question. You just give it a try. Integral cos 2x minus cos 2 alpha divided by cos x minus cos alpha into dx. How this could be done, we don't have a separate formula for this, and if we split also there is no hope. Then how this could be done? No girl. See, use cos C minus cos D formula. Minus 2 sin C plus D by 2 sin C minus D by 2. Use this formula and figure it out. Okay.